Hi, Jonathan. Last week we talked about BIM model standards. Can you explain me about that?
Yeah, if you remember, we talked about this idea that if you've got a BIM execution document, that part of that is to define what the model standards are. And what I mean by that is if you design a wall, how are you going to classify that wall in your CAD or in your BIM document so that other people who look at that know what the classification of that is? So, for example, AutoCAD uses layers. What layer will that wall be on? If Revit uses something similar to that. Vectorworks uses something similar to that. ArchiCAD uses layers as well. What layer will that wall be on so that we can then make that layer invisible when we want to? So, in other words, control visibility. And if you wanted to do a report where you were scheduling the walls or scheduling the information, you need to have a consistent system so you can say, find all the walls and report the material on the cladding. Give me the area of the material on the cladding. So it's really important that we have some kind of agreed standard to help find all that information. Now, when I was working in London, we used a system, I think it was a European system called CI/SFB. And I think it's a Swedish system, but it had this really nice, easy to follow matrix. So you'd say element two, these are things, the structure of the envelope of the building, I think it was 2 dash. So if we go down to 2.1, those are the walls. 2.1 was exterior walls. 2.2 was interior walls. 3.1 was secondary elements in walls. So 3.1 would be windows. If you went to 4.1, I think was the finish of the wall. And so the matrix went down for the elements and across for the complexity. So you'd start with 2.1 would be the primary element, 3.1 would be secondary elements, 4.1 would be the next part, and so on. And then it had a very easy to follow matrix. Now, no one here in New Zealand wanted to use it, but it did mean that we had a consistent way of creating drawing numbers because we'd use it for drawing numbers. It had I think that we use part of that CISFB system when we teach architectural technology because we talk about LACS, location,
Yeah.
assembly, components, and schedules. And that comes out of that CISFB system, the location and the assembly and the components, so that you would actually use that as part of that CISFB system. That we're not using CISFB, but there's got to be something that we use. And if we start to look at the advancement of BIM and the need to have a model system, now I could come up with my own model naming conventions and I could give you my file, but I'd also have to create a document that told you what my numbering system was for those elements. So I'd have to say, oh, my walls are on the class 21 dash walls or something like that. Now, there's a couple of systems we use in New Zealand at the moment. One of them is the Coordinated Building Information System, which is used by MasterSpec. The challenge that I've got with that is that the MasterSpec numbers are not related to a drawing system. They're related to specification systems. So they work really well for specifications. They work really well for your library, but I'm not sure that they relate to drawing numbering or element naming.
It's more related to rocks and quantifying. So it's more related. It's not very good for the drawing when you produce drawings. So master spec CBI is not very good for drawings, but when it's quite good for quantify the rocks. So that's why my quantity surveying students love it, but architectural technology students doesn't know what it is about. It's that's what happened in my classroom.
I can understand that they like that because you look at 23 carpentry in the master spec system, then all the QS, all they have to do is go, all of this is carpentry. It fits into that system. They can then look at the specification clauses, and the CBI had that nice breaking down. So it's not just 23 carpentry, it's 23 something else, which is, it gradually defines it. And they use a 4 number system to define
Yeah,
studs.
yeah.
So the QS can easily look at those and see what the studs are
It's
and so
called,
on.
I think it's called rock breakdown structure. So that's why they It's easy for a QS, even for my students who are studying quantity surveying, they don't have site experience. Some of them, yes, some of them don't, because some of them, they just straight out from the secondary school, but they find it easy and it's a useful guideline to, so master spec. And by the way, let's go back to the drawings systems again.
What do you mean?
Oh, let's go back to the drawing family and layering systems.
Okay, so since that doesn't do what we need it to do, there must be another system. We know that CISFB isn't going to do what we want, but there is the appearance of something called what was it called? The Uniclass system. Now, the Uniclass system is a way of identifying building elements in an international way, so that if we all accepted this, there would be an international classing system for classing all of our objects. Now, I was just having a look at Master Spec. They do have a document about Open BIM and how those documents or how those elements are called, but it didn't cover how we attach those as model standards. So in other words, an IFC element door, it doesn't tell you what classification system that door is on to allow you to do either scheduling or to do reporting or to do visibility, that kind of thing. Whereas this system here called the Uniclass Unified Construction Classification System has a series of tables that control activities, complexes, entities, spaces, elements, systems, and products, and so on. Now, it appears that complexes would be, for example, if we were doing a domestic building, complexes are a collection of buildings together, a collection of houses together, a subdivision, for example. Entities would be each house within that complex. The spaces would be the spaces in that, whether that room is a kitchen, dining, living. And then we get down into elements, and the elements would be this is a wall, this is a door, and those elements should give us the structure to allow us to control visibility of those objects. So, for example, we have EF, which is elements functions, walls, EF25 is walls, EF2510 is walls specifically, and then that's broken down further to EF2510, 25 is external walls. We've got internal walls is EF2510, 40. Now, I found this very confusing to see all of this stuff in these lists, and I really struggled to get it together. But I found that if I put it into an Excel spreadsheet, that it was actually a lot easier for me to look at, because you can put all the walls together, you can put the roofs together, you can put the floors together, and so on. And it makes a much easier to see structural system, or a classification system, I should call it. I'm not sure I want to go through the entire Uniclass setting up an Excel spreadsheet to do that, but I could do it if you want, Ethan, for site, wall, roof, floors, ceilings, just to give the idea of how that system would work. What do you think?
Yeah, how do you want to show to the audience? Do you want to
I thought
show?
if I made an Excel spreadsheet, I could stick it in my Dropbox and put a link in the show notes.
Oh, that's cool. That's cool. Yeah, that's an example of how you did it. And yeah,
So to me, when we go back, if we look back at the BIM execution plan, the BIM execution plan had an area where it has to define model standards. And to me, if you're going to create a BIM model, building information model, and you're going to give that to somebody, and in 10 years' time, someone else is going to pick that up, that it has to use a system which is internationally agreed, or at least nationally agreed. And the trouble I think we have here in New Zealand is that there are too many people that want their own numbering or their own classification system. And it would be a good idea, I think, at our colleges to start teaching Uniclass system of element classification, so that students start using a considered system. I wonder what you thought.
yeah, for the drafting schools, we should introduce at least there are several different systems as well, so we can introduce Uniclass systems or other drawing systems to the students so that they have awareness when they go to the design studios. And because in New Zealand, their design studios have their own system. We are talking like last week, we discussed about information sharings between the organizations and the execution plan, how we want to execute across different organizations. So that's really important how you want to define your elements, your function, your systems, and work together. That's a really important step. And yeah, I agree with you. We need to teach the students about at least a system like Uniclass system, so that will be much better.
My challenge with the Uniclass system is that it doesn't go far enough. So, for example, it's got EF. So, for external walls, we've got EF 25, 10, 25 external walls, which is great. Sounds like it's going to do everything. Is that wall an existing wall? Is it a proposed wall? Is it a demolished wall? Is it an existing wall that's going to be reused? Those are not
Yeah.
covered by the Uniclass codes. And then if we look at the wall components, we've got the structural components and we've got the non-structural components, and it doesn't include those either. So to me, there's still some stuff missing. For example, there
Yeah.
should be external wall components and then the components inside the wall. Because if you think of the components, if we look at a timber frame wall, we've got the timber frame wall, then we've got the lining on the inside. So that's a non-structural element. And then we've got the cladding on the outside, the air gap, the rigid air barrier, if it's rigid, or building wrap, if it's building wrap. And so the classification system from Uniclass doesn't cover those in that level of detail.
That's quite deep. I didn't think about that. What you mentioned is quite actual applications when you go to the box, and there are some you highlight the gaps of the Uniclass system. I think that's it's a valuable insight.
Then we also need to look at the Uniclass system and see if it involves drawings. We'll have to look at that. There is the title sheet, the contextual insertion, setting out topography. So the Uniclass system also includes what they call ZZ-CAD, so the CAD drawings. And so we'll need to look at that in a little bit more detail. I thought we'd looked at this in detail, Ethan. I suspect we
Yeah,
haven't looked at enough detail. We might have to come back and revisit this. But if you've got a comment, please leave a comment in the comment section on Spotify, and it'll give us great information about what you'd like to hear more about. And
and see
I'm
you
not
next
sure.
week. And
See you next week.
yeah,
Don't forget to go to Spotify and subscribe.